Ji, Bismillahirrahmanirrahim. So, welcome to today's lecture. So, as you know that we were discussing a lot of physiochemical processes, and again, this is our new topic, which is known as extraction process. And in this process, we will discuss in detail three processes. One will be liquid-liquid extraction, and then there are some minor part of extraction of this part, which is known as maceration and percolation. So going toward this, first of all, I just want to share that what is the objective of our this today's lecture. That what we are going to decide in this lecture. That after discussing this lecture, what will we get? What we will learn? Basically, if you come to know that extraction process is just like isolation process. When you take this process isolation, then there are the two other terms which are very close to this. One is a separation term, and another most good one is a purification term. So basically, we have discussed this a lot previously. When we take that this is a separation technique, it means that if you want two things to separate from one another, so you just get one thing from other, and this can be separated. But the term purification is more related to our pharmaceutical sciences because the substance which is basically your target one, when you separate from undesired, then it is purified. For example, there is a compound which contain 4 or 5 mixtures, and out of these 4 or 5 mixture, one compound is your relevant topic, your topic you can say reagent, what you can say. And if you separate that concerned compound from the remaining, then this process will be separation. But technically, we are doing a purification process. So basically, the first thing that this extraction process is done for what purpose? So what is the objective of our today's lecture? So just very simply that nowadays technology is very advanced. We are using a lot of different technologies to make drug molecule. But when there was no technology, we get all the drugs from crude drugs. Crude drugs are what? They are just part of some medicine plant. Any plant root, any plant leaf, any plant seeds, they can be a source of different phytochemicals. The word used as phytochemical, and then these phytochemicals come in the market. Nowadays they are called as a drug molecule, and they call different name as well. So basically, for example, I give a lot of example of, for example, when there was no technology and there was very common disease of malaria. So what the people do, they just chew a bark which was known as cinchona bark. Basically, what was going on? Basically, there was a phytochemical in that cinchona bark which was known as quinine. So this quinine was basically an anti-malarial phytochemical. So what the technology did? No technology doing this, that you are just getting this phytochemical from that plant and just separating it, and when you came to know the chemical structure of that compound, then you are just making it artificially. So basically, the removal of that quinine from that crude drug in pure form is known as extraction. So basically, extraction is what? This is a separation technique. When you say that there was a cinchona, so basically, what was happened? This was a cinchona plant, and there was, for example, 50 chemical in it, and we want to separate the one chemical out of that 50 chemical. So this is known as a separation process. We will come later on that there is a lot of techniques in which we can separate it. So out of these 50, when we separate one compound which is known as quinine, then this process will be separation, and this phenomena will basically called as a purification process. So basically, extraction process is one of the separation technique. Yeah, more better word. Extraction is one of the purification techniques in which we separate the desired compounds from undesired compound. यानी आपके raw material में there are two type of compound which are wanted and some are unwanted. So we can separate them. So basically, our this topic will cover all these parameters, that how we will do this, mean how the desired compound will be separated from unwanted compound. Our first target, when we will separate, what type of technologies, what type of methodologies, what type of solvent being used, because this is a very, you can say, time taking and very lengthy process, and we have to do a lot of things because to separate a target compound from unwanted is not an easy task. It is very difficult task still, because the main problem is that there are a lot of chemicals which have the same chemical structure. Even there are a lot of ways by which we can separate them. For example, the first and easy thing is their molecular weight. For example, one thing is of small molecular weight, another is of higher molecular weight. So you can easily separate them from different chromatography techniques because they have some different molecular weight. But if the two molecules have same molecular weight, then it will be difficult for that metal. Then we go toward the next stage, which is their ionic charge. We call that their polarity. If there is one compound which is more molar, another one is less polar, so we can separate them. But again, if there are two compounds which are of same molecular weight and same polarity, again it will be very difficult. So there are a lot of technique. We can take a lot of column chromatography, we can use TLC, but these are the old techniques, and nowadays the most relevant is LCMS, and this is liquid chromatography mass spectrometry. This is the latest technique by which we are going to separate the compound from one another. So these are all the process. So you can say a simple word that these are the advanced technology with application of this extraction phenomenon. See? So simple words, the main objective of our today lecture, that how we can separate a drug from the crude drug. Crude drug is basically part of a plant, which can be a root, which can be a stem, which can be a leaf, because the medicinal plant contain these phytochemicals in their special parts. There are some plants which contain a lot of phytochemical in their roots. There are some plants which contain a lot of phytochemical in their seeds, and it all depends. There are more than 80,000 basically these chemicals which are being used. दोबारा शुरू करना पड़ेगा क्या मैं? अच्छा चले. Okay जी. So we were discussing about that how we can achieve this target. So there is a lot of technologies, a lot of methodology. We will discuss later on. So just simply starting the basic part of this lecture. So here you can see that I just told you in detail that this is a separator technique. And separation of what? Separation of your desired compound, which is basically some drug molecules, and they are being done by use of some solvent. So if I tell you in a little bit detail, so what will happen? The compounds which are basically soluble, they can be separated from that crude drug. What will happen? Basically, a simple explanation, that we will take the crude drug, we will convert into powder form after size reduction, and we then soak this powder in some liquid. So what will happen? The compound which will be soluble in that solvent, they will be separated from that crude drug. And this is the method of. If I give an example from our daily life, the best example is just your tea bags. Tea bags are best example of some crude drug. When you put it in a hot water, then the desired constituent, which are some caffeine and some other compound, they are extracted from that tea bag into the water, and you just enjoy a tea. So basically, the tea is just everyday life best example of extraction, that you achieve your desired particle. So the basic phenomena which is based on this is just a solubility phenomenon. But again, the question is this, that if your compound is insoluble in that solvent, then the target will not be achieved. So to answer this question, basically for extraction process, we not use a single solvent. We use more than one solvent. So because there are some compounds, because in plants, sometimes there are alkaloids, sometimes there are flavonoids, sometimes there are waxes, there are sometimes resins, a lot of chemicals. And all these chemicals has different solubility phenomena. So there are some phytochemicals which are water soluble. There are some phytochemicals which are alcohol soluble. There are some in different organic soluble. So if we take only one solvent, then the compound will be soluble only which are in that solvent, other will not extracted. So the basic thing is that we will extract all the basic compound from that crude drug, and then we will go for their separation. So basically we will use a solvent, and then the basic property is basically the solubility. So basically there are three basic terms. First is separation, second is use of solvent, and the third, the most important one, is their solubility. And what you will achieve? You will achieve by these four parameters. First, the solvent will penetrate in the solid matrix. Next, the solute will dissolve and they come out of that particle. And then the solute will diffuse into solid matrix. And the last one is that extract will be collected. So, if you see here, the diagrammatic relation, or you can say the next thing is that there are a lot of factors which can affect, they can be diffusibility. Next, the most important is the particle size, solvent ratio, duration, and temperature. So particle size has a very, very good influence of this section. Smaller the crude drug particle are, better will be the extraction. Then how much amount of solvent should be taken against how much amount of crude drug. This is very important. If the drug is in large quantity and solvent is less, the extraction will not be okay. If it's in opposite phenomena, then again your process. So selection of crude drug, and there is no hard and fast rule that how much quantity of drug mean crude drug, which is basically we are going to separate, and how much solvent. So there is no general criteria that how much drug should be taken against how much solvent. So there are basically hit and trial method, but the quantity should be sufficient that it should be dissolved. It should be a solution form. Mean the solvent should be in large quantity as compared to the drug molecule, so it can be extracted. And next is the temperature. There is a lot of compounds which are insoluble at low temperature, but it should increase little bit temperature, even 30, 40, then show some better. So keeping in mind that what type of compound you are going to be separate, and also know their solubility temperature, it will give you a better idea that what should be the temperature during which you are doing the extraction. And the next important one is duration. Basically what happens when you take a crude drugs powder, you will put it in the mixture of solvent, then the solvent always takes some time for this separation phenomena. This time in some cases can be 1 to 2 weeks as well. That's why I tell you that nowadays technology has the main influence of this duration, because I always say that time is money. A process which take a lot of time, it always have a much more cost as well. So if you want to introduce a method in a manufacturing industry, so the first parameter they will see that in how much time this process will be completed. So if there are two methods, one is taking 1 day and other is taking 7 or 10 days. So industry will never go toward that method which is giving almost 10 days. They will always prefer a 1 day, because the basic thing is that time is money. So in nowadays the technology is shifting that there should be a process which should take less time. There is a lot of, for example, if you go in the technology, the today nowadays latest technology is microwave assistant technology, and this is basically a replacement of different chemical reactions. Even I give you a previous example that in my PhD chemical work, there was two methods. First of all, we was going to manufacture our cellulose, which was taking almost 7 days. But then we replaced it with microwave technology, and it took just 5 to 7 minutes. So this is a way that we are just switching the technology. So this method, even at the end, we will go toward some limitation as well, and we will come to know that this method, the main limitation is its long duration. Even if you are doing a research and you have very less time, and you just soak a crude drug in a mixture of solvent and just waiting and waiting for 1 to 2 weeks, so it makes no sense. So the main problem is that this method takes some time, more time as well. So this is a simple diagram in which you can see this is known as a separating funnel. So mostly the apparatus, the, you can say the chemicals, you can say the thing is basically a funnel. If you can see that what's going on, basically the black dots are your drug of choice which you want to separate. This is your desired chemical, and then this greenish or blue shade is basically the solvent, and you can say that you put that drug in the solvent. Then in next stage you are just shaking it, little bit shake it. Shaking always increase the degree of solubility. If there is something which is insoluble and you just stir it, just shake it continuously, then it will increase its solubility, it will increase the process of extraction. And in the last phase, you can say, basically in the first phase, there was two solvent which was mixed. And remember, the most important thing which maybe I not discussed earlier, that when you will take solvent, I told you that these solvents should be more than one. So for example, I say that you are taking two solvent. And remember, the selection of solvents should be in that way that these solvent must be immiscible with each other. Immiscible with each other. For example, if you put water and alcohol either, they will make a homogeneous mixture. So there will be no difference between water and alcohol. Just like you melt some water in milk, they will make a simple again homogeneous solution. So there will be no difference. But if you put oil in water, they will not miscible with each other. They will make the two separate layers. So remember, for extraction process, the selection of solvent should be in such a way that the solvent must remain immiscible with each other. They should not mix. Even if you shake them and you just put them for some time, they will again divide into different layers, and this layer will be basically based on their density. The denser liquid will be in the bottom side and the lighter substances will be the upper side. And again, because the simple theory is this, that there are some chemical which will be dissolved in upper layer, there are some chemical which dissolve in lower level, and to separate them is easy, because what will happen, there is a tab in the bottom. When they will become in two layers, you can see that a lot of compound are black in an upper part and only minor compound is this. So when you open the tape, then first job, maybe it will be more good if I go to the next slide. So basically, this is a more better example. If you see that there are some upper part which is a solvent, which is a light phase, and you can see a lot of green and red dots. Basically, these are the compound you want to separate. So what you do, you just mix it. When you mix it, then there is basically two phases. One is a dispersed phase and other is a continuous phase. And that's the most important one, is phase separation, in which you say that the red particle are on upper part and the green particle in lower part. But you can see that there are still some green particle in red particle, but there are some red particle in green particle. Basically, we never say that when you do the phenomena of extraction, it will extract the substance in a 100% manner. We never claim this, that extraction will give you 100% purification. Yeah, you can say that 100% separation. So if you can say that in the first case there was not at all anything in the solvent, but you mix them with different solvent, and at the end you get two phases, and in two phases there is almost more than 95% separation. Mean 95% red dots are separated from the green dots. So basically this is the way that how, even a more better example, that I have some video for you, so you can see the process of this. So we can just make them as this, so you can see that what's going on. So basically there is a technique in which basically we are doing this phenomena. So you can see that in this video, this is basically a separating funnel, and this is basically solvent 1, which is basically organic solvent, and in this case basically this is ether, which is organic solvent. And what we are doing, that we are just shaking it a little bit, and now we are just removing the stirrer from it, and we are just washing it so that there should be no loss of the chemical. So what happened, we just transfer it into a separating funnel with the help of a funnel. So with the help of funnel, we transfer into a separating funnel. So this was done. So what is going on? So basically we are just rinsing it so that if there is some remaining part, because there are some solvent which are very costly, so we do not want to waste, and because we want to then add another solvent which is water, so that's why we are adding some water as well. So basically there are two phases in it. The lower phase, which you see that it will be yellowish, this is ether, and upper one is basically water, and you just close it because there are some solvent which are very volatile, so they will be lost. And then the most important one is mixing. There are two immiscible solvent, and the one thing maybe I just tell you before this, that basically in this figure, in this picture, we are just giving you an idea what will happen. The basic thing is there that we will put a compound which we want to separate in this as well. So this is just a video to show you that how the layer are basically separated. So this is a basically visualization picture just to give you a better idea, because in theory sometimes it's very difficult to visualize that what's going on. So basically actually this is a lab work. We took first of one solvent, and then we took a second solvent. Basically this was a water and ether, and both solvent are basically immiscible each other. And what we will do, we will put some drug in it. Some drug means some crude drug, a powder of a crushed leaves of any plant, or powder of a stem of any plant as well. And we will put this powder in this mixture, and we will just shake it. And when we will shake it, there will be some drug which will be dissolved in water, and there will be some part of the chemical which dissolve in the organic, because there are two type of compound. One are known as hydrophilic, and other one is known as hydrophobic. So hydrophobic and hydrophilic will show different phenomena. So all the hydrophobic compound will be in that organic phase, which is ether here case, and all the hydrophilic compound which are basically freely water soluble, which are water loving, they will dissolve in water. So what we will do then, just to see that how they are separated, they are just showing you all this technique. So we just mix them, and when we let it stand, then it will just separate in two base layer. You can see that upper layer is yellowish layer, and lower layer is basically clear layer, which is basically water. So when we will open the tap, the lower phase will be separated, and this lower phase not only separated, it will separate all the particles which are dissolved in it as well. So then we will replace the upper layer which will be separated, and when they will be separated, the next phase is that how you will extract from these plant from that organic layer. So this is basically next phase that how we'll do. So you just see that he will open the layer tab and just remove the lower part, and then we will just replace it with the upper part as well. So this is a technique by which we can do a lot of these experiments.
But if we take a solvent in large quantity, can it affect the composition of drugs?
Yeah, definitely. The question is this: if we take one solvent in large quantity and one solvent in low quantity, then what will happen? So basically, it will depend that in crude drug, how much amount of drug is soluble in that solvent. For example, if you take a crude drug in which lot of compound are soluble in organic solvent, then your organic phase should be in much quantity as compared to other phase. So, and keeping in mind that now technology is so advanced, almost all the work is done. So you always know that what type of chemical, yeah, better word is petrochemical are present in that compound which you are going to extract. So when you know the nature of the separated compound already, so then you can easily adjust. And there is no such rule that you will take the solvent in 50-50 ratio. They can be 70-30, because if your compound which you are going to extract is more organic solvent, then why we will take it less quantity? The more the solvent, more chances of its extraction with increased volume. So this is really a very good question that we also keep in mind, that how your compound are separated in what type of solvent. Even there are some cases in which we take 3 solvent as well. And they can be in any ratio. They can be 20-30-50. They can be 40-30-30, depending upon which compound is soluble in which type of solvent. So the compound which has very less solubility, the solvent should be less quantity, and that solvent which can absorb a lot of solute particle should be in large quantity. Next thing which we are discussing that when you take a solvent, then there is a lot of parameters which kept in mind, and the most important one is solubility and selectivity. I told a little bit earlier that the selection of solvent depends that how it can dissolve a substance. If the solvent can dissolve more substances, then it should be selected. The next is immiscibility. I told you earlier that all the solvent selected for separation must be immiscible. They should not diffuse with each other. They should not generate a homogeneous solution. They must be in different layers. Just the best example is oil and water. Next is boiling point. Boiling point is basically the point which is linked with its evaporation. Because if you use organic solvent which has very less boiling point, then it will be evaporated. For example, there is some solvent which just evaporate in little bit higher than room temperature. There are a lot of organic solvent which even separate at 35 degree, and even in Pakistan in summer the normal room temperature is almost this degree, because if there is no air conditioning, so that if you are doing extraction, then your solvent become to evaporate on that temperature, and it will not give you the proper results. So the organic solvent selected must have some higher boiling point so that they cannot be evaporated during the process of extraction. Then toxicity and safety. You can never compromise with this, because these are the solvent then can cause, there are two types of toxicity. For example, if you are using a solvent which then evaporating and going inside the body in the form of some views and causing toxicity to your body. Another recommendation is that when you are doing this extraction process, it should always be under a fume hood. So fume hood, what will do? It will just absorb all the fumes which are if separated from the organic solvent. But again, there are some chances, even if you are working on the wound as well. So there are use of such solvent which should not be toxic. Then is cost and recovery. The most important then when you will use this compound, when they will dissolve a chemical, then what will be happen? We will then separate that separated compound from that solvent as well. So when we will evaporate, there are a lot of ways. The simplest way is rotavapor. Rotavapor will do to just take a solvent that will contain your desired chemical and just evaporate it. So compound will be evaporated and then condensed, and then it will be recovered, and then the desired compound will be separated. So this is basically known as a recovery method, because when you will do this, that solvent can be used easily for some other purpose as well, because that compound dissolves the substance, and then that dissolved substance was separated from that solvent, and then that solvent is absolutely in pure form. This can be used because these organic solvents are sometimes very, very expensive. So if you are just reusing that solvent, then it will decrease the cost of your whole process. Then is chemical inerness, mean there are some cases that your solvent is just reactive with your desired compound. If you are separating a compound, you separated it from the crude drug, but that chemical is then reacted with the solvent, then I think so there will be no end result, because your end product is just reactive with the solvent and it will convert to some other product. So there is a end result will be nothing. So select a solvent which just dissolve the desired compound, not interact with it. So there should be no reaction of solvent with that desired chemical. It just dissolve it and just we can separate it. Then density is very important. Sometimes there are very, very dense compounds which are difficult to dissolve. So optimum density is always preferred. Next is the physical property. And physical properties, all these parameters, their boiling point, their reactivity, all these parameters can be again discussed. So these are the basically criteria which must be kept in mind when you are going to discuss. So there are some examples just to show you that water is basically widely used for this purpose, and water has known as universal solvent as well, because the number of chemical water can dissolve. There is no chemical in the world which can dissolve. But again, there is some limitation as well. There is a lot of even compound which are not dissolved in the water as well. But we are talking about number. So water is the best choice. Then is a lot of compound which are insoluble in water as well. You can see the list. And its main advantage is it's cheap because it's easily available, non-toxic, non-flammable, and highly polar. So polarity is sometimes very ideal for separating some compound. The main disadvantage is that the mechanical growth. I told you earlier in our previous lecture that stability of any drug is poor if it contains water content. So if you keep the formulation away from the water, it will be more because the water is always ideal for microbial contamination. So microbial contamination is in this case. Another thing we just discussed in our last lecture that there are a lot of things which cause the instability of drug, and the most important one was hydrolysis. If there will be water, it will just break down the drug molecule and it will destroy it, and it will be known as its degradation. So next is fermentation, again a process which highly depend on this water as well. So there are some other two solvents. You can say the alcohol. So alcohol has some better property. The main advantage of this is that it causes no microbial growth because alcohol is basically antibacterial agent. It is sometimes used as a preservative as well. If you want to control the microorganism, just to make a 90% alcohol and it will just give you, even you can use that a lot of sanitizer are using alcohol because when you use a sanitizer, it's just want to kill the microbes which are attached your hands as well. So basically dissolve selected anticontaminant, and it is costly and flammable and volatile. So there are some things which are basically disadvantage, that the cost, it will have more cost, and then the flammability, you know better, and then the volatile nature. Volatile nature is basically leads toward the loss of that compound. And another example is basically chloroform. This is another organic solvent, and the main advantage of this that it is colorless, it has soluble in alcohol, and it absorbs our metabolism in the body. But the main disadvantage is its more dangerous property, which are basically known as carcinogenic. These are basically some cancer-causing properties. So we can't compromise on these properties. So there are so the one line that when you are selecting a solvent, then you have to select a solvent with all these parameters in mind. If a solvent which is highly volatile, which is highly mean cost, and second is this more dangerous factor, then its selection will be avoided. So you can replace this solvent with some other solvent which has not these properties. So if you have to select two solvent which is highly volatile, which is non-volatile, just go for that. Then you can compare them in cost factor, and then you can compare them with their safety parameter as well. So keeping all these parameters, and remember there are huge variety of solvent nowadays because in nanotechnology the solubility of drug is a huge problem because there is a lot of compound which are water insoluble, and a lot of nanotechnology research is going on, which is basically used to increase the solubility of drug, and for that purpose we are being used a lot of solvent. So there is a huge list of all these chemicals available, so you can use and try any type of this chemical. Next, the second part of our lecture is types of resection. So basically there are three types. One is liquid-liquid, then is solid phase, and then is solid-liquid. Just one liner. In liquid-liquid section, all the discussion which we have discussed was basically about liquid-liquid. Liquid-liquid means that we are making two solvent. Mean one is organic and one is aqueous, and they are both liquid-liquid, and one thing is absorbed in liquid, one organic, and then we are just going to separate it. And in next phase there is a solid phase. In solid phase, the thing is that there will be a use of solvent, but there will be no other solvent. There will be basically one thing which will be a solid, and another will be basically a liquid. So basically you can remove a solid from the liquid, and then is basically solid liquid section. So there is a very minor difference between this. Maybe I discuss later on to show you that how they are basically separated. So basically this is liquid liquor section. We have discussed in detail, I think so previously. So this is basically some lines about this liquid section. So basically these are suitable immiscible solvents, you can know, and then basically component distribute themselves. We have a lot of study about this, that some compound will be soluble in phase 1, some will be soluble in phase 2, and these phase 2 will be basically separated, and both the feed solvent or homogeneous mixture are separated by conducting them with one another to separate out one of them with liquid. This was the way we talk about the video. Then we will open the tab and just remove the one solvent and then the next one. And the last thing is that this technique is most commonly used for aromatic compound for amplium. So there is a lot of plants which contain some aromatic solvent in it. So we just replace them with them. Next is basically solid phase section. This is basically a picture. I will show you some video that how they work. Basically, if you see that first there are basically 5 stages. First is conditioning, then equilibrium, and then loading, washing, and elution. Basically, in conditioning, we are just making to prepare the solvent, that what type of solvent we are using. So this is basically a preparation stage in which we use a conditioner. Then is equilibrium stage. Basically, here we use another term which is known as sorption. Basically, there are two terms which are very close to each other. One is sorption and another is leaching. Basically, sorption and leaching are the two phenomena which are basically highly relevant to each other, and they are sometimes opposite to each other as well. So remember, this sorption is basically used in solid phase reaction, and this leaching is basically used in the last phenomena, which are basically we will discuss later on, which is basically solid liquid. So basically what will happen, that if you see in third slide, which is loading, basically the first one, which is showing the crystal shape analytes, we want to separate it from these impurities, which can be any type, just to show them that there are some green color, some yellowish color, and some reddish color. So these are basically XYZ impurity. So if you can see that there is a junction in the this tube. So this junction is basically a sorbent. From sorption, this is basically a sorbent. Sorbent is very much near to adsorbent. Maybe you know the word adsorbent. If one thing is absorbed on the surface of other, is known as adsorbent. So basically, there is a adsorbent. We just put a liquid in it, and what will happen? The three things: analytes, and then reddish impurity and yellowish impurity remain there, but the greenish impurity just pass through, and then it is lost. Then we go to next stage, washing. Then we wash. Then and this washing is done with different solvent. Here in first case, we use that solvent in which that green impurity was soluble. Then we move toward next, and then we use that solvent in which that yellowish impurity was solvent. Then it is separated, and next we see that now there are two things. One is basically reddish impurity and your that crystal color analytes. So there are two options, that you take that thing in which your analyte is soluble, or take that substance in which your impurity is soluble. So in this case, when we take another thing, then impurity retained, but that was soluble analytes, so it is separated. So from all these four things, maybe you can see this another video. So you can see it from this paragraph, that how they can be separated. So you can see that 5 steps. So here you can see that first is conditioner step. Just we are just getting ready your problem, what type of solution it is. So we are just taking the solution which we want to do for this purpose. Then we are just putting some adsorbent, that how it will just release the product. So this is second step in which we put some solvent. Next is your mixture of analytes and this. So one thing is remaining, as you can see that green color is just going down because it was soluble in that part. And the fourth stage is another dye which is yellowish color. It is soluble in this solvent and it will just pass through and it will also be removed as well. So yellowish color is removed. And the last is two things. One is red color dye impurity and analytes. So this impurity is insoluble. It will remain over the solvent and your analytes will be separated. So this is the techniques basically we use for this purpose. So next you can see that basically solid liquid extraction. So basically here a very simple technique and we will use the phenomena of leaching as well. So leaching and sorption, basically if you want to do this, basically sometimes if there is a container and if there are some salt in it, so there are two options. Sometimes these salt absorb on the wall of container and sometimes there is something on the wall which came in the liquid. So if you can see that the two terms, one is liquid, solid is coming within the liquid, and another thing is solid is attaching on the surface of solvent. So basically in previous lecture, which was sorption, basically this was the phenomenon that solid is attaching on the walls of that solid. But in leaching, the solid is just like a washing phenomenon. When you wash, the stain comes with liquid and it's removed from the clothes and we can get the neat and thing. So basically this is a solid liquid extraction in which you are just replacing this phenomenon from other purpose. So you can see that detail of leaching and mixture of solvent and solvent dissolve these specific. So basically the last two things which we have to discuss is just to maybe in next lecture we will discuss later on is this maceration. Basically these are the methods which are known as maceration, percolation, decoction, digestion, infusion, and Soxhlet, a very good technique, Sox extraction. Then microwave assisted, I was talking about sonication, accelerated solid extraction, and supercritical fluid extraction. So basically, these are all the techniques which are being used. And just remember that the later part is discussing some advanced extraction technique. And the initial part, starting from maceration to infusion, these are the basically old traditional ways. And the main difference between first part and second part is the timing. This, for example, Soxhlet extraction gives you extraction in very less time as compared to percolation or maceration, which sometimes take more than 1 month as well. Maceration is none other than to soak a something. You just take a crude drug and soak in the solvent and just forget it for more than 1 month because it is a very time consuming technique. Because this crude drug will soak, it will expand, and from this period it takes a lot of time. So that's why it will be abnormal. So I think so in our next lecture, inshallah, we will discuss these processes in detail. Up till now, if there is any question, so you are highly welcome to Vikarji.
Sir, extraction is basically a purification process, but there are also some other purification process like sedimentation, crystallization. So why extraction?
So the question is that there is a lot of methods because we have discussed, I think so, whole chapter of these physico-chemical process, and I think so after one lecture, every other lecture say that this is a purification technique, this is a separation technique. So question is this that this is again a purification technique, this is a separation technique. Then why this is different from? So basically the reason is this that there is no doubt a lot of physiochemical reaction going on, but there are limitations. Every process cannot be used for anything separation. For example, if I talk about TLC, so TLC is a method in which we take a stationary phase and we just put a solvent on it and it rises on it and it will separate the compound. But there is a lot of solvent which can't do this phenomenon because they cannot rise on that stationary phase. One thing. Second thing is that there is other problem of that if the compound are non-polar, they will not separate from this column chromatography as well. So basically, the difference is this that how or what thing you are going to observe. are separate, because here in this case you are going to separate different drug molecule, and drug molecule are basically very sensitive, and sometimes they are heat sensitive as well, and sometimes they are very large compound. To separate them from this technique is very difficult, and the basic and the simplest technology used in this solubility. For example, if you put something in a water or you put something in alcohol and it is soluble in it, then it will be separated from that mixture. So this is the simplest way without costing any energy. But I told you that the main problem of this method along with simplicity is time consumption. It takes much more time for that separation. So that's why nowadays I just talking about these micro assistant and this Soxlet. These are being technique which are again working on the basic phenomena of solubility as well, but they are taking less time because they are promoting this separation phenomena with some different techniques. Basically, the way that how you extract or what things you are going to extract is the way, that's the variation in different ways. Any other question? No? So I think so this is all about our today's lecture. So I think so next lecture we will go toward the next part, which will be the method to extract different substances. So this is all about our today's lecture. Thanks for your patience.